Hello viewers, Ragdarana taking you through the story of A-Level Physics Paper 2. And this video I'm going to go through the topic of progressive and stationary waves. So this video is suitable for students in both Senior 5 and Senior 6 offering physics as part of their combination. So before we proceed, let's first look at the course outline of this paper. So Physics Part 2 is divided into 4 parts. The first part is geometrical optics, where 2 questions come from these topics. Second part is physical optics, where 2 questions come from these topics. The third part is electrostatics and electricity, where 3 questions come from these topics. And the fourth part is magnetism and AC, where 3 questions come from these topics. So you already completed the part of geometrical optics and electrostatics and electricity, and now we are on the part of physical optics. So physical optics, the first topic can be divided into subtopics. So we are divided into 4 subtopics, and that will be progressive and stationary waves, waves in pipes and strings, Doppler effect and its applications, and lastly bits. So in this video we shall go through the part of, or the subtopic of, progressive and stationary waves. So it should be remembered that here we are interested in the calculations, but complete notes are available in the book called Mastering A-Level Physics Part 2, which contains clear notes, worked examples, and trial questions on all the part topics of Physics Paper 2. So when you're buying, I encourage you to buy edition 2023 because it has been updated. So for copies of this book, I encourage you to contact the author on any of these 2 contacts. But a complete set of physics has 3 books. There is Physics Paper 1, Physics Paper 2, and a topical question bank. Then for Principal Mathematics, there are also 3 books: Math Paper 1, Math Paper 2, and a topical question bank. Then for Subsidiary Math, it is only 1 book, and the rest are for O-Level. So for any of these copies, contact the author on these contacts. So now we shall start our topic. So this video is on progressive and stationary waves. So there are 2 parts. There's a part of progressive waves and a part of stationary waves. So let's start with the part of progressive waves. So by definition, a progressive wave is one that carries energy away from its source through a medium and spreads out continuously. And the vibrations of the particles are of the same amplitude and frequency, but phase of vibration keeps on changing from point to point. So here we have a little of the theory, and the theory on this video is to help you understand the calculation. So don't think that the theory found on this video is complete. It is incomplete. The complete theory is in the books I've encouraged you to buy. So here we are interested in the calculations, and in the books everything is there. So shall I try to derive an equation for a progressive wave. So this circle helps you to get the motion of the wave. So if it starts from here, go in this direction, it will be represented graphically in that form. So from here up to here is this motion from here up to here. Then from here up to here is this motion from here up to here. And from here up to here is this motion from here up to here. Then lastly from here up to here is this motion from here up to here. So that means that from this point, moving in this direction, and up to this point, it will have made a complete revolution. So this will be a complete a complete cycle. That is why we are seeing here wavelength. So wavelength is the distance covered for one complete cycle. That means that if it moves from this point up to here, it implies that now at this point, remember this circle of radius a, but in waves we don't call this radius, we call it amplitude. Then x is the horizontal displacement, y is the vertical displacement. So graphically, this point P will be at this point. Remember, we said from here up to here is this motion up here. Then when it goes up to here is this motion up to this point. So our x, so this x is supposed to be from here up to this point. That is your x. And y is this. So x is this, y is that. That means that I can get, this is a right angle triangle, I can get y in terms of a and theta by saying that sine theta is equal to y, which is opposite, over a, which is hypotenuse. So I'll come here and say that sine theta is y over a, implying that y is a sine theta. So if theta is an angle in radians, it implies that theta is equal to omega t. I think remember this under the topic of circular motion in physics paper 1. So angular velocity is the rate of change in the angle. So theta over t is omega. When I make theta a subject, I'll come up with omega t. And when I substitute for theta, I'll come up with a sine omega t. Then I also remember that omega in terms of frequency is 2 pi f. Therefore, substitute for omega to come up with y equal to a sine 2 pi ft as the equation for y. Now from there we shall see that since the wave is moving to the right, the motion of the particle P will lag behind. Lag is like a delay, lag behind the particle O, that of particle O, by a time this. So remember, t is the period, time taken to cover a complete cycle. Then x and wavelength or lambda is the total distance taken to cover a complete cycle. So a fraction, time taken to cover a fraction of this cycle, that is where this comes from, x over lambda times t. Because if lambda is for a complete cycle, then x is for t, it implies that x over lambda is equal to t over capital T. Then from there I will need to make this small t the subject to come up with, by taking this on this side, to come up with x over lambda times capital T, which is this you are seeing here, x over lambda times capital T, where t is the period of motion. So now we shall see that the displacement of P is therefore given by replacing small t in the equation by t minus xt over lambda. Minus because they said lagging behind. If it was ahead, it would have been plus. So that means that when you substitute that here, where there was t, we shall put there the whole of this. And when I bring this f inside, I'll come up with ft minus xf capital T over lambda. But we know that frequency is equal to 1 over period, inverse of period. Therefore, I'll come and substitute where there was f, I'll come and put there 1 over t. Remember here it was, if you go back here, using this, not this, but using this first. Where there is f, I put there 1 over capital T to come up with this point. Come up with 2 pi over capital T in brackets t minus xt over lambda. Okay, then another thing, that is one way of expressing. Now we have begun expressing the equations of progressive waves. It can be expressed in this form. Okay, then another way can be expressed by bringing this capital T inside. When I bring it inside, I'll come up with 2 pi out, and inside there will be x over t here. Then this 1 over t times this, it will cancel with this to remain with x over lambda. That is a second way of expressing a progressive wave. Now, what is the third way? A third way is remembering that 1 over t is f. Therefore, here where there is this t, I'll replace it with this 1 over t, I'll replace it with f to give you the third expression of a progressive wave. Now, all these expressions we are getting are vital, as we shall see when we begin doing the worked examples. Also, I can choose to, now this one comes from this part. So when I bring the whole of this in the first part here, if I bring the whole of this 2 pi f inside, what will I get? I'll come up with this. I'll come up with this. So 2 pi ft minus 2 pi x over lambda. And also furthermore, I can say that why don't I make the whole of this be equal to a constant, which is k. So I'll come up with this part, 2 pi ft minus kx. Okay, then I also remember that why don't I make this 2 pi f equal to omega. That's when I come up with this other expression. So any of these 6 ways, these are the 6 ways of expressing the equation of a progressive wave, and all of them are vital, as we shall see when we start doing the calculations. So here k is the wave number and is equal to 2 pi over lambda. So the general progressive wave equation is given by plus or minus. So here they can be plus or minus. Remember, when you are starting, we said it lags behind. That is why we are maintaining the minus in our equations, but it can also be plus. Now, what is the difference between the two? When there is a minus, it means that the wave is moving from left to right. It's moving towards the right. And when there is a plus, it means that the wave is moving from right to left, or towards the left. So when you get an equation of a progressive wave and they have put plus here, just know that the direction of motion is from left to right. If they have put a minus, it is from left. First is from left to right, from right to left, and here it is from left to right. Okay, so with that we can go through these questions. Question 1 came from UNEB 2011 paper 2 question 3b, and it says figure 2 below shows a wave traveling in the x direction away from the origin with a velocity of 9 meters per second. Roman 1, what is the period of the wave? And Roman 2, show that the displacement equation of the wave is given by this. So in this graphical representation, you realize that the wavelength, remember wavelength is the distance from here up to here, and that distance is 1.2 centimeters. That will be the wavelength. Then they have given us the velocity 9 meters per second. Therefore, if I know the wavelength and I know the velocity, it means I can get my period. by saying period is equal to 1 over f, and 1 over f is equal to lambda over v. So lambda is this, you change it to meters, and v is 9. We are changing it to meters because our v is in terms of meters per second. So this one should also be in meters, it can't be in seconds. And when I use a calculator, I'll come up with the period as this. Then Roman 2, they say that show that the displacement equation of the wave is given by that. So remember the general form of a wave moving from left to right is in that form, where A is the amplitude, F is the frequency, X horizontal displacement, and lambda is the wavelength. So now I know the wavelength, it's here. I know the amplitude. If I come back to the diagram, amplitude is 2 and 2 centimeters, which is here. Amplitude is 2 centimeters. Then frequency is V over lambda, which is 750 Hz. Therefore, I'll come and substitute. Substitute for amplitude, substitute for frequency, and substitute for wavelength. Okay, so now here in this bracket, I'll get the LCM to come up with this. After that, I'll take this 1.2 outside, and the outside to come up with this. Then from there, when I reduce this, I'll come up with 5 over 3. So 2 divided by 1.2, when you reduce it, it becomes 5 over 3. And this is what they wanted. So that was question 1. Now we shall go to question 2, which came from U.A.C.E of 1994, paper 2, question 3C. And it says, a wave of amplitude 0.2, wavelength 2 meters, and frequency 50 Hz propagates in the positive x direction. If initially displacement is 0 at point x equal to 0, Roman 1, write the expression for the displacement of the wave at any time t. And part B, find the speed of the wave. So good enough, we have amplitude, we have wavelength, and we have frequency, and we have the direction. So you can come and quote the formula A sine 2 pi ft minus 2 pi x over lambda. Then you substitute. Amplitude was 0.2, frequency was 50, and lambda was 2. So we'll come up with this as the equation they wanted. Then Roman 2, they wanted the speed. So speed will be f times lambda. F is 50, lambda is 2 to give you 100 meters per second. And that's what they wanted. Then question 3 came from U.A.C.E of 2006, paper 2, question 1B, and it says the displacement y of a wave traveling in the x direction is given at time t by this. Find the speed of the wave. So here we are going to compare that equation with the general equation. That is why I told you that all the 6 expressions of the equation of a progressive wave are needed. So now we are going to use this expression because it is similar to this. So here there is A, it is okay, there is 2 pi, there is t here, but the denominator there is capital T, meaning that the period of motion is 0.5. Then there is x here, and below there is lambda, and here there is 2, meaning that the wavelength is 2. So shall come and say that capital T is 0.5 and wavelength is 2 meters. We are using meters because of this here. So now that I have T, I can come and get the velocity by saying velocity is equal to frequency times wavelength, and frequency is 1 over T. So come and substitute for T and the wavelength to give you the speed they wanted. Question 4 came from U.A.C.E 2018, paper 2, question 3b, and it says that displacement y over progressive wave is given as this. Okay, where x is the horizontal displacement, horizontal distance in meters, and t is the time in seconds. Determine Roman 1 the velocity of the wave, and Roman 2 the maximum velocity of the particles of the medium. So that is the equation we have, and we shall compare it with the generic form which is here. So by comparison, you will realize that when this one comes inside, you come up with pi t, and here you have 2 pi t over t when you bring this one inside. So I'm going to compare this one with this to give me this part here. Okay, then I will cancel out pi, I'll cancel out t. Here this side I remain with 1, this side I remain with 2 over capital T. Then cross multiply to get capital T as 2, and that will be the period. Then also, when I bring this pi inside here, I'll come up with pi x over 20, which is here. Then when I bring this 2 pi here, I'll come up with 2 pi x over lambda, which is here. So I'll equate the two. When I equate, pi will cancel, x will cancel, so you remain with 1 over 20, and here it will be 2 over lambda. Cross multiply, lambda will be equal to 40 meters. Therefore, the speed will be equal to frequency times wavelength. Frequency is 1 over capital T, and the good thing, we know the value of capital T, so come and substitute for capital T and substitute for the wavelength to give you the speed they wanted. Then Roman 2, they wanted maximum speed. Maximum speed is omega times amplitude. So omega is 2 pi f and amplitude is here. So 2 pi is here, f is a half because period is 2, therefore 1 over t will give you 1 over 2. Then the amplitude was 2. When you use the calculator, you'll come up with this as the maximum speed. That was question 4. What about question 5? Question 5 came from U.A.C.E of 2004, paper 2, question 4c, and it says, a sound wave propagating in the x direction is given by the equation this. Okay, find the amplitude and Roman 2 the speed of the wave. So this is what is given. Then I'll compare it with the general equation which is in that form. So now I compare, realize that this A is equal to this. So amplitude, I've already got the amplitude. Then for Roman 2, they want the speed. So I have to first get the frequency. So by comparison, this one, the whole of this is equal to the whole of this. So I'll come and equate the two and make f the subject. Then also by comparison, this is equal to this. So I'll equate them and get the value of wavelength. Now that I have frequency and wavelength, I can get the speed they wanted. Question 6 came from U.A.C.E 1999, paper 2, question 4b, and it says the displacement of a particle in a progressive wave is this, where x and y are in centimeters and t is in seconds. Calculate Roman 1 the wavelength of the wave, and Roman 2 the velocity of propagation of the wave. So first of all, that's the equation I'm given. Then by comparison, I'll compare it with this equation. You realize that this A is equal to 2. It's in centimeters because that's what we are told. Then the frequency, it means that here and here, this F is equal to 100. Then from this and this, it implies that 1 over lambda is equal to 0.25. Therefore, lambda is 4 centimeters. When you convert to meters, it will be 0.04. And that is the wavelength in Roman 1. Roman 2, they wanted the velocity. The good thing, I have F and I have lambda. So I can get the velocity they wanted as 4 meters per second. So that was the equation of a progressive wave. Now we shall go to what we call phase difference of two waves. So for a wave whose equation is expressed in the form this, phi is what we call the phase angle. So it is expressed in terms of omega t minus something here. What is there is what we call the phase angle. So by comparison with this, which was the general equation, which was one of the equations of a progressive wave, you realize that the phase angle is kx, and k was 2 pi over lambda. So phase angle is 2 pi x over lambda. But we are interested in the difference. So that means that the phase difference, delta phi is equal to 2 pi times delta x over lambda. So what if you are given two waves of different frequencies? If you see here there is omega 1 and here there is omega 2. How do you get the phase difference? Phase difference still will be got by getting the difference between this and this. So when I subtract them, I'll come up with this. It is magnitude because sometimes this one might be bigger than this, but our interest is a positive value. So substitute for K1, substitute for K2 to come up with this as the expression for the phase difference given the wavelengths of two waves. What if you are given frequency? You remember that wavelength is equal to V over F. Therefore, come and substitute where there was wavelength, put there V over F to come up with this as the expression for phase difference in terms of frequency. This was in terms of wavelengths, in terms of frequency. So with that, we shall go through these questions. Question 1 came from UNEB, 2019, paper 2, question 4B, and it says, when a plane wave traverses a medium, the displacement of the particles is given by this, where y and x are in meters and t in seconds. Calculate Roman 1, the frequency of the wave, Roman 2, the wavelength, and Roman 3, the phase difference at a given instant of time between two particles 50 meters apart. So we shall start with part A, that is the equation you are given, then we shall compare it with the general equation, which is that. So we realize that now frequency is 2. Then for Roman 2, compare still this with this, you realize that wavelength is 100 meters. Then the one phase difference is 2 pi delta x over lambda. 2 pi delta x is the distance apart, and lambda is 100. You come up with this as the phase difference. Then question 2 came from UNEB of 1994, paper 2, question 3D, and it says, two waves of frequencies this and this, respectively, travel with a speed of 340 meters per second through a medium. Find the phase difference at a point 2 meters from where they were initially in phase. So we know F1, we know F2, we know V, we know X. Therefore, the equation will be in this form, and this is what will help us to get the phase difference. Or if not, you can quote the formula we derived of phase difference in terms of frequency. But if not, then you can first go through this, then you can, after that you will substitute. And after substituting, you come up with this as the answer they wanted. So now shall go to what we call stationary waves. We have been looking at progressive waves, and now shall go to stationary waves. So a stationary wave is a wave pattern that results when two progressive waves of equal frequency and amplitude but traveling in the same direction, same speed, but in opposite direction, are superposed. So you have this word superposed or superposition, which is what it means. So superposition of two such waves results in points where displacement is always zero, and those points are called nodes, as we shall see, and points with maximum displacement, or points where displacement is maximum, and shall call them antinodes. So let's try to illustrate that. So that is one wave traveling in this direction. Then the other one will be traveling in this direction. So that is what they mean by opposite. So they told you nodes are points with zero displacement. That is why this point here is what we call a node. Then antinodes are points with maximum displacement. So from here to here, there is maximum displacement. So those will be the antinodes. So that is how a stationary wave is represented. So each time you see such a wave, just know it is a stationary wave. And the maximum displacement is antinode, zero displacement, or this midpoint is the node. So that this will be the wavelength from here up to here. So that is very vital because it will be used especially in the next video of waves in pipes and strings. We shall need this idea. Then this one, distance between two antinodes is half wavelength, and also distance between two nodes is half wavelength. So with that, we shall now go to the derivation for the equation of a stationary wave. So we shall consider a progressive wave whose displacement is given by that. Now remember, they told us the condition is that they should be traveling in opposite direction, but with the same speed, same amplitude, and same velocity. So what is changing is the direction, meaning if this is minus, the opposite direction, it will be plus. That is why you are seeing that this one now, it has changed to plus here. Because this one was moving to the left and this is now moving to the right. Now when the when two waves superpose, the resulting wave is given by this, so you have to add the two. Now this addition of trig, it's assumed that in your pure mathematics you have covered the topic of trigonometry, because from this step onwards we shall need what we call factor formula. So factor formula means that the whole of this becomes, first of all, this is a, you first factorize out the a, which is here. Okay, then this one sine this plus sine this gives you 2 times cos this and sine this. Now cos, how is cos coming about? Cos, you get this one minus this one and you divide by 2. You'll get a negative, but negative cos the same as positive cos. That is why here we just have positive. Or to make it easier, you are going to say this angle here minus this angle to get 2kx, then you divide by 2. Okay, then for sine you will add this plus this, you'll come up with 2 omega t, then you divide by 2. Now what I've done is what we call factor formula. So if you have not yet covered it in trigonometry, I encourage you to first watch that video in mathematics of trigonometry, especially the part of factor formula, because that is what we need each time there is superposition of a wave. Then I simplify this one, these 2 cancels and these 2 cancels, so I'm going to remain with 2a cos kx sine omega t. So that this one can be written in this form, where a is equal to the whole of this. So here we have said that since the resulting amplitude, this, so this is the amplitude, it varies with distance x, it implies that the resulting wave is a stationary wave. So for a stationary wave, the amplitude must vary with distance x. So with that, we shall go through these questions. Question 1 came from UNEB 2022, that is this last year. Paper 1, question 3b, and it says a progressive wave is given by the equation this, where t is the time in seconds and x is the displacement in centimeters. Roman 1. Write down the equation of a progressive wave that superimposes or superposes the above to form a stationary wave. Okay, then 2, using the given progressive wave equation and the equation written in Roman 1 above, determine the equation of the resulting stationary wave and state its amplitude. Okay, Roman 3, calculate the wavelength of the stationary wave in B Roman 2. Roman 4, determine the phase difference between 2 points on the progressive wave separated by 25 centimeters. So just start with Roman 1. Roman 1, they want a progressive wave which superimposes with this to form a stationary wave. What you need to know is that frequency remains the same, amplitude remains the same, and speed remains the same, but the direction changes. That means that what we need to do is to just change this sign. If it is minus here, then the second wave will have plus. If this was plus, the second wave will have sign. But now in this question, it has minus, meaning the wave they want must have a plus. As simple as that. So let's go and write it down. So that will be the wave they want for Roman 1. Then for Roman 2, using the given progressive wave equation and the equation written in Roman 1 above, determine the equation of the resulting stationary wave. and state its amplitude. So there you have, they want us to add. So resulting wave is got by adding the two waves. And adding means you need the knowledge of factor formula to give you that. So this plus this gives you 600 pi t, then you divide by 2. Then this minus this gives you 2 pi x over 15 divided by 2 to give you this. Then I simplify, this times this is 40, this divided by 2 gives you this, and this cancels with this to remain with that. So I've rearranged to put the x this side because it's an amplitude, it's part of the amplitude. Then this 300 comes this side to give you this expression. So in this case, the whole of this is what we call the amplitude. So that's what they wanted. So this is the resulting wave, and this is the amplitude. Then they also wanted the wavelength of the stationary wave. So by comparison, remember frequency remains the same and speed remains the same, meaning that wavelength also remains the same. So what we need, we shall just go back to this one and get the wavelength. So this one is equal to 2 pi x over lambda. Therefore lambda will be equal to 30 centimeters. Then Roman 4, they wanted the phase difference. So phase difference is given by the formula 2 pi delta x times divided by lambda. So 2 pi is there, delta x is the distance apart, and lambda is the wavelength. So we'll come up with this. But in physics we are not allowed to leave our answer in fraction form, so you have to get the decimal, and that's what they wanted. So in physics, never leave your answer in fraction form. It is not okay. Then question 2 came from U.A.C.E of November 1998, part 2, question 3b, and it says a progressive wave is given by this, where x and y are in millimeters and t is in seconds. Roman 1, write the equation of the progressive wave which would give rise to a stationary wave if superimposed on the one above. Okay, then Roman 2, find the equation of the stationary wave and hence determine the amplitude of vibration. Then Roman 4, determine the frequency and velocity of the stationary wave. So here it was minus, meaning the new wave will have plus. As simple as that. So you come and say that, write the equation with a plus. Then 2, they wanted the equation of the stationary wave and the value of the amplitude and the value of amplitude. So you come and say that the resulting wave is got by adding the 2. So by factor formula, we shall come up with that. Then we simplify to get the equation of the stationary wave. But they wanted amplitude, so amplitude will be given by that. So this all of this is the amplitude. Then Roman 3, they wanted the velocity, the frequency and velocity of the stationary wave. So by comparison, frequency is equal to 2 pi f is equal to 100 pi t, so f will be equal to 50. Then the velocity will be 0 because it is stationary. Then question 3 came from U.A.C.E of 2000, paper 2, question 3d, and it says a progressive and stationary wave each has a frequency of 240 Hz and speed of 80 meters per second. Calculate Roman 1 the phase difference between two vibrating points in the progressive wave which are 6 centimeters apart. So this is delta x. Then Roman 2, the distance between nodes in the stationary wave. Remember, distance between nodes is half wavelength. So first phase difference is 2 pi times delta x over lambda. 2 pi is there, delta x is there, then 1 over lambda is the same as f over v. So I'll substitute for delta x and for frequency and for velocity to come up with the phase difference. Then distance between nodes is half wavelength, so half times wavelength, wavelength is v over f. So substitute for v and for f to come up with this as the distance between the nodes. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on waves in pipes and strings. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.